Next up was training the data using the machine learning models. And as part of the model training, step number 1 was to declare the independent and dependent variables. So here, the dependent variable signified by the letter Y is the column charges. And the reason is simple. The rule of thumb is dependent variable is the column or is the variable that I'm trying to predict. So in this business problem, the organization is trying to estimate or predict the total amount of charges each application might have in the future. And that is why the variable charges qualify as a dependent variable. And as part of the machine learning models that I build, I will be taking an attempt to predict this charge for each new application that gets submitted. On the other hand, by capital X, I'm declaring rest all of the variables in the data set. And they are the independent variables. The independent variables are important as they are leveraged to predict the dependent variable. That means all the other columns in the dataset are taken into account into the computation that is performed by the machine learning model. And as a result of that computation, the dependent variable, which is the charge, is predicted. Okay. Now, you may notice that I have declared the independent variables in the letter capital X, while smaller case y is used to declare the dependent variable. And the reason for that is dependent variable is always one individual variable or column. And in the terms of mathematics or algebra, it's called a vector. And vector is always represented as a lowercase term. On the other hand, independent variables more often have multiple columns stacked into them, or multiple variables are taken into account. And in the terms of mathematics and algebra or computing, it's called matrix. And matrix are always represented by an uppercase alphabet or letter. So that is why I have used X in uppercase for the independent variables and Y in the lowercase for the dependent variable. Up next is a very important method of training the data or training the model for machine learning, and it's called the train, test, split. And in this process, I have divided this entire data set in two parts. One part is called the training data set, and this training data set is used to train the models. All the machine learning models that I have created, I have fed them this training set or training split of the data so that the machine learning models can observe the data and understand their relationship and learn the patterns and the behaviors. Once that is done, then in order to check the performance level and the intelligence of the machine learning model, I will be passing on values from the testing set to see how the model is giving the output on the basis of the training that it has received. Pretty much like how we have learned at the school, right? We have been trained for a significant period of time. We have been given a lot of data from the different subjects like maths, physics, science, etc. And then we have been given tests or examinations to see how are we able to perform on the basis of the trainings that we have received. So it's pretty much the same concept that I have applied here. So here I have imported the train test split mechanism from the scikit-learn library, which is a library dedicated for machine learning related use cases. And after that, I have created the splits for training and testing. So I have created the training data set for both independent variable X and the dependent variable Y. And similarly, I have created the splits of test data for both X and Y, right? And the way I have instructed the machine to create the split is 70-30. That means out of the entire data set, I have instructed the machine to take 70% of the data on a random basis. So I have not told the machine that, okay, these are the records or these are the rows that you take. I have conditioned the machine to randomly collect 70% of the data of the records and then conduct a training on the basis of that to understand the relationship, the patterns, and the behavior within the data. Now comes the most intriguing part, which is selecting the machine learning models. Now here I have selected 6 different types of machine learning models in order to build this application. And the reason is, if I train or build my application only on 1 or 2 machine learning algorithms, then I might risk the fact that there could be a model that may deliver better results than the one that I have chosen. So in order to avoid that risk, I have selected all the possible machine learning algorithms that can fit this specific use case or the specific problem statement that I'm trying to tackle. Okay, so what are the algorithms that I'm going to use here? The first one is called the linear regression. The second one is called support vector regression. The third one is named the decision tree regression. The fourth one is called the random forest regression. The fifth one goes with the name of gradient boosting regression. And the last one is called extreme gradient boosting regression. Okay. These are the list of algorithms that I'm going to train my models on. So after all the machine learning models or algorithms have been imported, now it is time for training the model. So in the model training process, to each of the model, I have given the training set of the data, both the independent variables and the dependent variable. So I have given this data to each of the models, and I have conditioned the model to observe the 70% of all the data, because that's the split I had created. And these models will feed all this data, the training set of data, and will observe what kind of patterns and relationships can be unveiled from this data. And once that is done, Then it is time to test the prediction results.